Welcome to this comprehensive walkthrough of customer segmentation using clustering in machine learning. In today's data-driven economy, understanding your customers is not just a competitive advantage, it's a business necessity. In this project, we explore a real-world financial dataset sourced from Hugging Face, containing detailed records of credit card clients. Using unsupervised learning techniques, we uncover distinct customer segments based on behavior and demographics. This journey takes us through the essential stages of a modern ML pipeline, from importing libraries and loading raw data, to cleaning, scaling, dimensionality reduction with PCA, and determining optimal clusters using k-means. Each step is visualized and profiled, ensuring that the resulting customer groups are both statistically valid and business relevant. Whether you're working in finance, marketing, retail, or telecom, the principles applied here are directly transferable to any industry that values customer insight. Let's dive in. Before we dive into any clustering logic, it's essential to set up our analytical environment. This block installs all required libraries, datasets, Scikit-learn, Pandas, Matplotlib, Seaborn, and Plotly. These tools collectively empower us to handle data, perform preprocessing, apply machine learning algorithms, and create both static and interactive visualizations. This is like fueling up before a road trip, non-negotiable and strategic. Here, we tap into Hugging Face's Open Dataset Hub to load the default of credit card clients dataset. This dataset simulates a real-world financial application, where each record represents a credit card customer along with behavioral and demographic attributes. The dataset is seamlessly transformed into a Pandas data frame, making it easier to manipulate and analyze downstream. This stage ensures our pipeline begins with real, meaningful data, essential for any industrial-grade machine learning project. With the data loaded, we now sanitize it. First, we remove the label column default.payment.next.month since clustering is an unsupervised task. Then, we drop the non-feature identifier ID and check for missing values to guarantee our clustering won't fail due to data gaps. This stage is the data hygiene checkpoint, just like ensuring all sensors in a machine are calibrated before running operations. Clustering algorithms like k-means are sensitive to scale because they use distance as a core metric. Here, we apply standard scaling to make all features zero-centered and unit variance. This prevents features like limit_BAL from dominating due to their large numeric range. This step mirrors industrial normalization, ensuring no single variable disproportionately influences the outcome. To reduce noise and computational load, we perform principal component analysis, PCA, retaining 95% of the variance. Our original 23 dimensions compress into 15, enabling us to run faster and visualize later. This dimensionality reduction also helps reveal hidden structure in the data, much like optimizing sensor signals to extract only relevant indicators. Determining the optimal number of clusters is critical. We use two trusted heuristics, the elbow method, which analyzes inertia, and the silhouette score, which measures cohesion versus separation. These plots guide us to a balanced k-value, striking a trade-off between underfitting and overfitting. This step is like deciding how many product lines to optimize for in a factory: too few, and you oversimplify; too many, and you over-engineer. With an optimal cluster count selected, here, k equals 5, we fit the k-means algorithm. Each customer is now assigned to a cluster. This is where data transitions from raw numeric abstraction to segment-based intelligence. Each segment can later be labeled, for instance, low risk high value, young with low balance, etc., enabling targeted business strategies. Using the first two PCA components, we plot customer clusters in 2D space. The plot visually confirms how well separated the clusters are, acting as a sanity check for the segmentation quality. Color-coded clusters help us spot tight groupings or outliers. This stage mimics a control room dashboard, quickly showing whether our segmentation is clean and actionable. We now calculate the average value of all features for each cluster. This gives a profile for every customer segment. For example, Cluster 0 may consist of younger users with medium credit limits and low bills, while Cluster May 3 indicate older customers with higher usage and better payment behavior. This summary is what business strategists love. It translates machine learning outcomes into human-readable customer personas. Finally, we save the enriched dataset, including the cluster assignment, into a CSV file. This allows seamless handover to other departments such as marketing, finance, or CRM teams. The file can also be fed into visualization tools, reporting dashboards, or further predictive models. It's like finishing the machining process and handing over the final product for packaging and distribution. You've just seen how clustering transforms raw, high-dimensional customer data into actionable intelligence. From identifying natural groupings in behavior to profiling each segment's financial patterns, we've built a full-stack solution that scales, visualizes, and delivers insights. This segmentation can now drive personalized campaigns, improve risk management, and inform strategic planning, ultimately reducing churn and increasing profitability. The saved output can feed into dashboards, CRMs, or even predictive models, giving your business a data-backed foundation for decision-making. As you continue developing machine learning solutions, remember, effective segmentation is not about creating perfect models, it's about generating meaningful divisions that business stakeholders can use confidently. Thank you for following along, and may your models be clean, your clusters distinct, and your insights profitable.